Hey guys, so here we are, lesson 3. We have staying in balance. So solving equations means you have to be balanced on both sides of your equal sign. You pretend it's like a balance beam or a scale, not a balance beam, more of a scale. So if it's leaning, that means these two sides don't equal each other. So we're going to work through those and see what we can do. So 3.1, hanging around. For diagram A, find one thing that must be true, and one thing that could be true, and one thing that cannot possibly be true. So I'm going to say one thing that must be true is that the triangle is greater than the square. Okay. One thing that could be true, well, the triangle could equal 10 and the square could equal 7. That could be true. And one thing that cannot possibly be true. Well, something that can't be true is that the triangle is equal to the square. It does not work. For diagram B, find one thing that must be true, one thing that could be true or false, and one thing that cannot possibly be true. So I have to go back because I just realized I didn't finish reading this right here. One thing that could be true or false. Well, this could be true. This triangle is 10 and the square is 7, but it can't be false because the value of the triangle is more than that. So we could say the square might be an even number, and no, triangle even, square odd. So coming back one more time. Well, for 1B, we were correct by saying that the triangle could be 10 and the square could be 7, because it could be true. Those could be the values. However, they might not be the values. So even or odd works. If you have 10 and 7, that works. The numbers, it might not be those numbers. So it could be 12 and 3. It could be any of those. We aren't sure yet. Okay, so now for diagram B. So find one thing that must be true. Well, one triangle is equal to 3 squares. Okay. Find one thing that could be true or false. Well, saying that they're equal, a triangle might equal 3, and one square might equal 1. So we'd have 1 square equal 1 and 1 square equal 1. Meaning the 3 squares are equal to 3. And one thing that cannot possibly be true. Well, we could say triangle is 3 and each square is 3. Oops, those squares aren't even at all. That can't be true because then we have 3 is equal to 9, and that does not work. 3.2. Matching the matching the equation and hangers. So these are called hangers. I call them scales, so I'll try my best to remember that. So we have to figure out which goes to which. So here we have 3 x's, and it equals 1, 2, 3, 4, 5, 6. So these are just like tape diagrams where you can add stuff up. So we have an x We have an X. We have an X. And I'm not going to put 6 ones. I'm just going to put 6. It's the same kind of thing where we now have 3 X's. It's not the same kind of thing. You guys, I am messing this video up left and right. And you know what? That's okay, because teachers make mistakes. And I'm fixing it right now. So they are not the same. They are the same in the fact that when you have this is a tape diagram. We have 3. And when you have this can be a tape diagram, and it is 6. And this is our equal sign because it's our scale balancing out the 2 sides. So if we were to have this as a tape diagram, we would have y plus 1, 2, 3 equals 1, 2, 3, 4, 5, 6. B, we would have this as a tape diagram. We have 6 equals, because this is my equal sign, and I have 1, 2, 3, 3z. And then our last one, we have 6. 1, 2, 3, 4, 5, 6. Our equal sign, W, plus, because it's our tape diagram, 1. So now let's match these up. So 3 times x equals 6. 3 times box, we don't know what that box is, equals 6. Well, so this goes with A. Now we have y plus 3 equals 6. Well, box plus 3 equals 6, so here's my y. This next one we have 6 equals, oh, we didn't put our letter above this one. This is B. 6 equals something plus 1. So I've used A and I've used B. So I have C. Well, that's 6 equals 3Z. So that doesn't work. So we have W. So we have C. Oh, see, there I go again. Just see how many times I can mess up in one video, guys. And the last one must be C, but let's double check. 6 equals 3 times something. Well, 6 equals 3 times Z. So that means that is our C. Next page. Oh, now we are writing them out. So we have 4 hangers. We have 4 boxes. We need to write an equation for each one. Explain how to reason with the diagram to find the weight of a piece with the letter. Explain how to reason with the equation to find the... I think I copied that down twice. Let's cross that off. Okay, so we have to write the equation, and then we have to reason on how to find the weight of the letter. So remember, this is our tape diagram number 1. This means equals because it's our scale. And then we have this. So for A, we have 3 plus, or x plus 3 equals 8. Well, this is addition. So we just need to figure out 3 plus how many more is 8. So down here I'm going to write 3 plus how many more equals 8. And there's a couple ways you can do it. One, you can use your fingers. Just count up 3, 4, 5, 6, 7, 8. It should be 5. Or we can solve the equation using the math that we're going to be going over. So just like the scale, I'm going to draw a line. This is my scale. It has to be even on both sides. So if I do something over here, I do it over here. So in order to get x by itself, I have to do the opposite of what's happening. So I have x plus 3. The opposite of plus 3 would be to minus 3. If I minus 3 here, I have to do it over here. Minus 3. This is 0, leaving me with x. 8 minus 3 is 5. And I could double check by plugging it in. 5 plus 3 equals 8. Well, 5, 6, 7, 8. I now have 8 is equal to 8. So that works. B. Okay. B. I have 12 equals 2y, because there's 2 of them. So this says 12 equals 2 times something. So we might say 2 times what is 12? This is my what? This is my y. Well, you might just count by 2s till you get to 12. 2, 4, 6, 8, 10, 12. Or we can use the steps in solving the equation. Each time I solve an equation, I always draw the line down the middle. So I keep my sides separated and I keep them balanced. This is 2 times y. What's the opposite of multiplying by 2? Well, the opposite would be to divide by 2. When you write it as a fraction, that also means to divide. Divide by 2. 2 divided by 2 is equal to 1. So that just leaves us with y. And then 12 divided by 2 is 6. Again, we can plug it in just like we did over here. 12 equals 2 times 6. We keep our 12. 2 times 6 is 12. That means it works. C. We have 11 equals 1, 2, 3, 4, z. This one won't give us a very happy number, but that's okay. So this is very similar. 4 times what equals 11? So I'm going to write this same statement down here. 4 times what is 11? Where what is my variable? We're trying to find that out. I can count by 4s. 4, 8, 12. That's not 11, so it doesn't work. So now we have to do our math. We have to figure out what are we going to multiply by. So draw my line down the center. 4 times z, the opposite of multiplying by 4, would be to divide, giving us 1z. And you don't have to write the 1 in front of it because it's constant. It doesn't affect its value. Calculator. Let's clear that big number out. 11 divided by 4, 2 3/4. 2 3/4. And then we can plug it in. 11 equals 4 times 2 3/4. 2 7/500 is the same. If I were to take it and multiply by 4, I should get 11. I do get 11. So 11 is equal to 11. Checks off. Oh, this next one we have fractions. But we can deal with that. So we have D. We have 13 4/5 is equal to W plus 3 4/5. Okay, so this sentence is going to be similar to this first one we wrote because we're adding. So 3 4/5 plus what? What is that variable we're looking for? Is 13 4/5. Well, in order to solve it, we have to do the opposite of what it's telling us to do. This is saying W plus something. The opposite adding would be to subtract. So minus 3 4/5. This cancels out, equals 0. Minus 3 4/5. So when you subtract fractions, they have to have the same denominator, so common denominators, and then you just keep your denominators the same. In this case, they're already common, so we don't need to change them. They are staying 5. However, if I have 4/5 and I take 4/5 away, I have nothing left. So I have nothing for my fraction. I have 0 over 5, which is nothing. And then I have 13 minus 3. That's 10. Equals W. I'm going to check my work down here. So 13 4/5 equals 10 plus 3 4/5. Since I don't have any fractions on 10, my 4/5 stays. I don't change that. I'm not adding anything to my fraction. And then I have 10 plus 3 is 13. It checks off. That is our lesson 3. If you want to read through the summary, you're welcome to. If you have questions, the summary should help you out. Otherwise, send me a Google Hangout or an email and I'll see what I can do to help you.